Have you ever stared into a pot of water as it heats up, watching those tiny bubbles appear out of nowhere, grow, dance, and then suddenly burst at the surface? It's one of those everyday kitchen moments that feels so ordinary, yet strangely mesmerizing, almost like the water is coming alive right before your eyes. But behind that simple boiling pot is a chain of invisible events happening at the molecular level, turning calm liquid into a restless, bubbling system. And once you understand what's really going on, it's hard not to see boiling water as a kind of quiet, scientific performance. Today, we will uncover the hidden story behind those rising bubbles, right here on History of Simple Things. At first glance, it might seem obvious what those bubbles are. Many people assume they're just air escaping from the water as it heats up. That idea makes sense intuitively. After all, we see bubbles in soda or when we blow through a straw. But boiling water works a bit differently. While some of the very first tiny bubbles you see are dissolved air escaping, the larger, rolling bubbles that define boiling are actually made of something else entirely: water vapor. To understand how those bubbles form, we need to zoom in, way in, to the level of molecules. Water is made up of countless tiny molecules constantly moving, even when it looks perfectly still. The hotter the water gets, the faster those molecules move. Temperature, at its core, is just a measure of how energetic those molecules are. As you start heating a pot of water, the molecules near the bottom, closest to the heat source, begin to gain energy first. They start moving faster, bumping into each other more forcefully. But at this early stage, something subtle happens before boiling even begins. You might notice tiny bubbles clinging to the bottom or sides of the pot. These aren't boiling bubbles yet. They're mostly dissolved gases like oxygen and nitrogen that were trapped in the water when it was cold. As the temperature rises, water becomes less capable of holding on to those gases, so they escape, forming small bubbles that drift upward. This is why freshly poured tap water often produces more of these early bubbles compared to water that's been boiled before. It's not boiling yet, it's just releasing what was already inside. But as the temperature keeps climbing, something more dramatic begins to happen. The water molecules gain enough energy to break free from the liquid state itself. Instead of just moving around each other, they start transitioning into a gas, water vapor. This is the key moment where true boiling bubbles begin to form. However, these vapor bubbles don't just appear randomly anywhere in the water. They typically form at specific spots called nucleation sites. These are tiny imperfections, microscopic scratches on the pot's surface, small bits of mineral deposits, or even tiny particles floating in the water. These spots make it easier for vapor bubbles to form because they provide a kind of foothold where the liquid can begin transitioning into gas. Without nucleation sites, forming a bubble is surprisingly difficult. In fact, under very controlled conditions, like in extremely smooth containers, water can sometimes be heated beyond its normal boiling point without forming bubbles at all. This is called superheating, and when bubbles finally do form, they can erupt suddenly and violently. Back in your kitchen, though, your pot is full of these tiny imperfections, so bubbles form more predictably. At first, they're small and tentative, But as the water approaches its boiling point around 100 degrees Celsius or 212 degrees Fahrenheit at sea level, these vapor bubbles start forming more rapidly. Now here's where things get interesting. When a bubble of water vapor forms at the bottom of the pot, it's surrounded by liquid water that is still slightly cooler and under pressure. If the bubble doesn't have enough energy, it collapses almost immediately. This is why, just before boiling, you might see bubbles forming and then shrinking or disappearing before they reach the surface. It's like the water is trying to boil, but not quite succeeding yet. As the temperature continues to rise, more and more bubbles manage to survive this journey. They grow larger, rise upward, and finally reach the surface where they burst and release water vapor into the air. At this point, you've reached a rolling boil, the stage where bubbles are forming continuously and vigorously throughout the liquid. What you're seeing now is a full transition from liquid to gas happening right inside the pot. The bubbles aren't just air. They are literally pockets of water that have turned into vapor, rising because they are less dense than the surrounding liquid. Another fascinating detail is that boiling doesn't just depend on temperature. It also depends on pressure. The boiling point of water is defined as the temperature at which the vapor pressure of water equals the surrounding atmospheric pressure. In simpler terms, it's when water molecules have enough energy to push back against the air, pressing down on them and escape as gas. This is why water boils at lower temperatures at higher altitudes, like in the mountains. With less atmospheric pressure pressing down, it's easier for vapor bubbles to form, so boiling happens sooner, even though the water isn't as hot. Back in your kitchen, though, at normal pressure, that steady 100 degrees Celsius threshold is where everything aligns perfectly. The water molecules have enough energy, the pressure conditions are just right, and bubbles can form freely and rise without collapsing. But there's one more layer to this story: movement. As bubbles rise, they don't just float quietly upward, they create currents within the water. Hot water from the bottom rises while cooler water sinks to take its place. This process, called convection, helps distribute heat throughout the pot, making boiling more uniform. That swirling, rolling motion you see during a full boil isn't just visual, it's a dynamic system where heat, motion, and phase change are all happening at once. So the next time you watch a pot of water come to a boil, you're not just looking at bubbles. You're witnessing molecules gaining energy, gases escaping, vapor forming, pressure being overcome, and convection currents swirling, all working together in a quiet, everyday transformation. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.